we'll do courtesy to our audience, and we'll start when we said we were going to start. And just in case you guys have forgotten, what we're going to be talking about today is, I framed it a little bit controversially, if you like, in the topic of when is eventually consistent not enough, and talk about consistency models in databases. But the key behind this is going to be, for us, is the different kinds of databases, and indeed data management tools, because they're not always databases per se, that you need in a modern, cloud native data layer if you're going to serve all the sorts of use cases that come along that an enterprise is going to throw at you. As in Yugabyte, we're talking about the operational use cases, and specifically most often about the ones where transactional consistency is important. But as I say, the portfolio of use cases as an engineer that you're going to be developing in the data layer is going to be wider than that. And so that's where I'd like to start. And David, I know you sent me some notes about what you describe as the modern data layer, which I sometimes describe as the heterogeneous data layer. But would you like to kick off and give us a definition of what you mean when you say modern data layer, and why you think that kind of requires multiple databases on the back of it?
Yeah, as a starting point, we've long had a view of the world of applications and a database sitting behind them. And that started to change quite dramatically when microservices came along. And that re-engineered how we thought about the application level. And we've done lots of work. We've got the Pivotals and of this world. We've got lots of tools now which are good at creating microservices. And suddenly you start to see what's the data stored in. So if you talk to Confluent, they will talk about eventually all the events being in a continuous stream. There's a strongly held view that you need transactional databases to store those important things like your bank account information. And then as well as that, you need analytical databases, and you might want to have search engines. And another part of this evolution over the last 10 years has been the fact that we no longer buy a database as an ecosystem. If you look at Oracle from 10 years ago, it's an ecosystem. It's not a database anymore. It's a collection of tools hung together to try and give you some things. But what's happened more and more over the last 10 years is people have gone back to the basics. We want to have an engine for doing messaging, or for analytics, or for transactional workload, which is best of breed, which does one job particularly well. And we don't want the hang-ons. There was this whole thing about moving to PL SQL. And now you see everybody trying to pull that business logic out of the PL SQL and put that back into the application layer, into the business layer higher up, and taking it away from the database. So when I talk about modern data layers, I'm talking about the collections of tools where you store persistent data in that tier, where you store persistent data within your architecture. And I think on top of that, there's a set of tools which your microservices, your applications, your UI interfaces, all of those sorts of things sit on top of that. And going further, I think below that is your cloud native type infrastructure, the ability to deploy these things on virtual machines or in Kubernetes or in Docker containers. And that includes data layer stuff, but that infrastructure. So there's a sort of infrastructure level, a modern data layer, and then some heading towards microservices and macro services running on top of that with UIs.
Christian, is that a scenario? Is that a worldview that you recognize? That's oh, you can disagree.
No. It's not a disagreement as much as you ask anyone who worked in this space long enough, you'd find similar worldviews, but you look at the world through different lenses, right? You look at it from different angles, but under the hood, right? We are talking about the same thing. So first of all, big shout out to one tool that does one thing and does it well. I am so sick and tired of every single vendor and SaaS service trying to provide me with the whole stack and trying to suck in all of the data and be like the analytical platform and everything for everything. It's just really annoying, and it's really hard when you try and build a platform in an organization. And by the way, I'm not Yugabyte, so if anyone wonders here, like I have no affiliation with Yugabyte. Like Dai and David, we've worked together before, so it's really no
we don't even
up
like
or down
each other,
for
Christian, let alone working together.
But
I don't
yeah,
know.
so coming back to the ecosystem. So when you try to architect a large-scale infrastructure in an organization, the data layer, of course, is a hugely important aspect. But it is made so difficult when you have these large pieces of technology and services that come in and try and suck up all of the data. So I'm coming from the world and the history of bringing together data sources in heterogeneous environments. And I'm sure a lot of people will understand this and it will resonate with them, because I think that's what we've done the last 10 years. Like most organizations over the last 10 plus years have tried to bring together multiple data sources, either because they had acquisitions or they have been organically growing. And that was kind of the big kickoff for Hadoop and everything. And David and I and Dai, we have worked in that space. And now we're looking at the Snowflakes and the S3 and Yugabytes and others in the world, right, that do this. But if you have to commit your data into every single architecture, you have no single platform where you have a version of truth. And that's one of these big problems that I have faced in organizations, where you can't go back and find a single version of truth, a reliable view of the world as it is for you as an organization. And that's why it's so nice, having such a long rant here, it's so nice to look at tools that have specific functions and ideas, and they do that well, right? Like the old idea of Unix, like have one little tool and it does something, it does that very well. And if you need more functionality, you add another tool. Sorry, I'm already going off on a tangent. I'll let you bring it back.
No. I want to go back. I want to go off on those tangents later, but I do want to bring it back, because there's something that both you and David threw into that, which was you talked about, yes, you're agreeing about best of breed, I think, is i.e., one tool, as you describe it, that does one job very well. But the key to that, you implied, Christian, and you actually said it, David, was that they have to fit into the infrastructure, to the stack. They have to play nicely with the others, if you like, the other tools at the same level, but they have to plug into the vertical thing. And so it's not just a matter of, oh yes, this is the best database for doing transactions or whatever. It's the best data for doing transactions that fits into my cloud native architecture, right? Am I paraphrasing you correctly, David?
Yeah, you can't afford to have something. I mean, agility in delivering applications in an organization, time to market, is about being able to do things. So if you have to orchestrate 50 different things, you've got a problem. If you want to orchestrate to the most common levels that you can. So you've got this dichotomy. You want to actually have all the features, so you should be able to find things that have those features, but you also want them to fit into your worldview of what that is. And yeah, when we deliver Yugabyte, one of the most interesting things you go out to 10 different banks. They all have a slightly different but opinionated view on what security should look like, on what their pipeline for deployment should look like. And none of them are wrong. They're different shades of gray and things, but everybody has built up. Most commonly these days, you'll see a Kubernetes cluster and this and this and this, and probably something like Okta to do the authentication and all these other things. But you have to be a team player as a component of an architecture. It's no longer sufficient to be just anything. You actually have to. Your product has to be a team player. It has to fit into the thing that people are likely to see. So it must run in Amazon and Google and GCP, because you may move tomorrow. If you want to move it, it must run. It must have APIs to make calls. It must do something like Prometheus metrics to demonstrate these things. Those are things that make your tool, whatever the tool is, database or application layer, they're what makes them team players, is the ability to fit them into different infrastructures and different design patterns that people have. And tools which aren't good team players are ones, even if they've got great functionality, you want to push to one side, because the cost of managing and implementing them is so much higher and than just dealing with the ones that do play nicely.
But do you think, Christian, I'm going to ask you the question, that the obvious follow-up question from what David's just said is, but do you then think that kind of practitioners, they start to have their, every to the man who has a hammer, everything looks like a nail, you know what I mean? They have their preferred set of tools and techniques and processes, and they kind of, it's not so much the vendor saying, oh yeah, I want to suck up all your data belong to me. It's more that sometimes as practitioners, we might bring our own biases from our past experiences and think, oh yeah, I can do that. I'll roll another one just like the last one, but they're actually not all the same, are they? What do you think?
Yeah, there's a lot of that, and there's definitely like the individual has a certain set of experiences, right? So it's natural, it's human. So if you have a problem at hand, you go back in your memory and say, like, what are the tools and technologies I worked with that I understand, that I can draw from? That's just normal. Or if you work in an organization that has already infrastructure or platforms or technologies, you look at the tools that are available, right? And if you have to hammer the nail in with a wrench, you use the wrench. It's not pretty though. Coming to David's point of the data layer, like one thing where it may stretch some people's imagination a little bit is kind of, you go in the world of the completely decoupled microservices, the Spotifys of this world, right? Where people say, well, you know what, let's have a cross-functional team with our software engineers, data engineers, UI people, etc. Like, your purpose in life is to make a payment service, or your purpose in life is to make a recommendation system, whatever else it is. And you have to communicate with the rest of the world. You can use whatever you want, right? Like, get your own toolbox. Like, if there's a team that loves C++, that's fine. If there's a team that loves Java, that's fine. And similarly, you can assemble your own technologies. That is nice, but it's an idealistic view of the world. I love this view, and I like to embrace it. And when I work with teams, I like to give teams and engineers as much freedom as possible, because the people you work with, especially the more senior one, in these teams, they have a boatload of experience, and you cannot like compete with the hundreds of years of experience across like large teams of the tools and technologies that they have used. So you have to not fight it, but draw on it. However, here comes the reality check. The reality check is twofold. One is platform, vendors, architecture is expensive and complicated. Like purchasing it, maintaining it, operating it, especially when you have like some very specialized infrastructure. So it makes sense for large organizations to converge towards a smaller tool set that they can afford, that they can maintain, that they can negotiate on, right? Like, even if it's not perfect, it's the 80-20 rule, right? If it does 80% of what you need, then maybe sometimes it is the easiest thing to use a wrench and not buy a golden hammer, because it's the one time you actually have to put in a nail. So sometimes that's a good answer. And the other problem is on the data side, and on the decoupling side, on the software and the data flows, right? It's like, if you have this world of these decoupled services, how in the world are they talking to each other, right? Like, oh yeah, in theory, that's all easy, right? Like, oh yeah, we're going to drop a message on Kafka and everyone's going to pick it up, and well, we have an API and we can communicate. But that's good for the first cut. Then, you know, like the second, third, fourth, fifth release comes in, the next feature, 10 services come in, other services come out. Like, what is the contract between these services? Both on the API level, but also on the data communication level, like which services are depending upon me and how do they interact with each other. So reality with these decoupled teams gets messy and difficult, both on the technology and the infrastructure side, but also on the decoupling side of the communication.
David, I'm going to ask you to pick that one up about APIs and the contract, because in financial services with open banking standards, and I know you've been working very closely with one of our partners in this area. Yeah. Yeah. How far does something like open banking APIs go to, meeting the need that Christian's talking about here? Or is that just kind of like a framework?
We're driving. These APIs are changing the world for open banking, and
Yeah.
we're in early May now. There'll be a big press announcement about some of the work we're doing with a bank in a couple of weeks' time, which talks about open banking. But drawing on that experience, the thing that they've said, which blew me away, was that a teller-based bank piece of work in a traditional bank had 3 or 4 select statements in a database and 1 update. And open banking has led them to have literally thousands of queries on the database, and then maybe 1 update at the end of it, or maybe none, because people just go in and check in the balance. I mean, this is the old world, the new world. The old world was, how often did you go into a bank? I mean, I certainly didn't back in the day go back and going to the bank every morning and check my balance, but I'll pick up my phone and do it, fairly regularly when I'm at home. And to Christian's point, all of this becomes challenging, because open banking is going to drive very long contracts with third parties for those APIs. So if you're open banking, what you provide, if you're a big major high street bank in the UK, and you say, this is my API for open banking, even if it's a standard, I've got to support that through all of my systems and all of my layers of my application. So if you give me a balance inquiry, what does that mean? It means going to this, and then it needs to authenticate that and get that token and pass that down all the way down to fetching it back from a database. And one of I was talking to one of the chief architects at this banking software house, and he was talking about the fact that they've split up their application into what he calls distribution and manufacturing. And with distribution, it's what you see in the app. And to go to the topic that we're covering today, he talks about that being a place where eventually consistent is good enough. The idea that if you're checking it, actually the fact that you haven't quite got the latest banking transaction is still very powerful in that distribution layer of information.
So you're saying that, you mean I check my balance on my phone in the morning, and if at the moment I do that, there is one transaction somewhere in the world actually going through, the restaurant I was in last night, they've finally got around to clearing that, or somebody has, then I might not see that, but that doesn't break my heart if that's not there.
That doesn't break your heart. And actually in my household, while I'm looking at the balance, my wife is busy spending it. So it's real time, and it doesn't have to be in the other part of the world.
I hope that was not a sexist remark.
No. It's a long and happy marriage, and my wife is the one who's in charge of all financial affairs.
That's all right.
As I'm sure both of you are as well. But in terms of but then you get to the point, at some point, and this is to the topic of this thing, and this is where you get this change, because suddenly this idea of an eventually consistent database, something like a Cassandra perhaps, is very powerful. It gives you that immediacy. It's fast, and it can be localized and distributed, and it doesn't really matter to some extent. But then you actually move the money. You actually move it from my bank account to your bank account. And you do not want that to be eventually consistent. Because what happens if somebody draws down twice? And then, how do you reconcile those things? This becomes transactional again. And that's where you get into your challenge, because up until relatively recently, what you were doing was you were taking money from one account to another, and that balance was being decremented with it and incremented on the other one. And if you want to get that process there, it has to happen in the back office. It has to be certain. Otherwise, what you'd have is two people taking money out of an account, and one of them eventually being told, actually, we can't service that payment because there's insufficient funds. So you start to build, and this is why the differences in microservice architectures and these different things in the data layer you start to, it's a good example for what we're talking about. The applications have to be able to use an appropriate store to deliver that functionality. So it has to be that if you want something really fast, close, and eventually consistent, it can be in the distribution layer, and that's fine. And if you have something which is transactionally consistent, you still have to have that, because when you move the money, it's there. And then you want an analytical database as well, because if you want to do something which comes along to one side of that, like what's the next best offer or what's my average spend, that's going to have some sort of MI or AI or some level of an analytical capability. So you need another store which is optimized for that sort of analytical store of information as well. So instantly, this modern data layer has got things which are eventually consistent because it's easy to service things, transactionally consistent because it's critical to what you actually do in the back office part of the service, and then analytical in terms of nature. And I know I'll shut up in a moment and let you have a go, Christian, because you can talk about some of your new stuff with the analytical stuff, but that's already 3 databases before you get to, do I want to do search or other types of technology events? And
yeah, we'll come back to things like search and graph queries and things like that, David. Yeah. But that was exactly the thought as you were talking about operational. You were talking about operational database, and you were identifying 2 different kinds that you might, the eventually consistent, which we talked about in the title of this chat, and the transactionally consistent. And then you said and an analytic engine, but Christian, I want to come to you and drill down on that and an analytic engine. So I just need to put Snowflake in my data layer and I'm sorted, am I?
No,
I knew you would say something.
We've established that if any vendor comes to you and say, like, I have the answer to all of your problems, walk away, right? Because they never have.
Run away.
Right? Like, some may do that, but it's absolutely not believable, and it's not a way to deal with problems. Yeah, you have different problems, you need different tools. And as you have with languages and with architectures, the same with the data layer and the data storage, right? Like, what do you want your data to do, right? Like, do you want fast retrieval? Do you want consistent transactions? Do you want bang for your buck, like scale out capability? The process is fast, right? Like, we have, depending on what you're trying to do, you have many, many different needs. And you have different types, classes of databases and data stores and query engines that do different things differently for good reasons. So anyone who thinks they have broken physics and they can do all of these things at the same time, it's just not true, right? You cannot do everything for everyone. That, I don't think that layer will ever be developed. I may stay corrected, right? Like, technology is amazing, so maybe in 100 years this comment sounds stupid, but today it isn't.
But it's all about best of breed, and just as David was kind of partitioning, even for the operational transactional part of it, is with transactional consistency versus other operational transactions which don't need immediate consistency. What you're saying, I'm asking is the same kind of that same dichotomy or trichotomy, if you want, apply in the analytic world?
Yeah, absolutely. I don't make the distinction anymore between like these big boxes, right? I'm just thinking about it in general terms. Probably have looked at too many problems over the years. But yes, so my go-to is always like, what's the most stupid, simplest solution I can get away with, right? That's what I start with. It's like not the fanciest, most advanced thing. And this is usually what makes the difference between someone who is experienced and someone who's junior. You ask a junior data scientist, like, I have a problem here, how do I solve it? It's like, oh, deep learning. It's like, no, you use like gradient descent or whatever you can get away with, like the simplest, most robust technology. And also, what are the parameters you're working with? So the company, little plug of my own work here, right? Like the company I started, Bold Data. If you're interested, bolddata.org. When I built this, it's a startup that I'm running myself, right? So I wanted it as cheap as chips, like as cheap as possible. So when I went into the data storage and data processing, that was my number one priority. But at the same time, I had to process a huge amount of data. So how do you square all of this? Like, how can you do large scale data processing, some analytical queries and lots of data movement and translation and wrangling, but do it cheaply? So I ended up doing Athena, right? So I actually really enjoy AWS Athena for that. Like, it's a completely different world from what Yugabyte does, right? Like, they're not even the same classroom, right? It's just completely different. But what that technology allowed me to do is do on-demand large-scale processing. Now, again, with technology like that, you have to know what you're doing. So if I would explain the class of problems I'm dealing with to 10 people in the industry, I don't even think 50% of them would think that you can solve it with a technology like Athena. But like, lucky for me, I had like decades of experience with Hive and other technologies that are related, right? So I knew the ins and outs from the storage layer, from the query engine, from the columnar storage, how to optimize the whole tool. And there's also some new technologies that are helping with it. So for example, DBT is a really neat tool that you can plug it together. Now, I'm probably going to get too technical and too nerdy here, but my point is, use the right technology, and sometimes that might be like, look at the things you know, right? Like, if you know good tools and you understand them well and they're a good fit, then go with it, because the cost of adopting something is also high, right? So if you have to go out and buy a new technology, that is also adding risk and cost. But there are a lot of developments in the recent past that have moved the needle on that, and Yugabyte is one of these things that have changed a little bit the needle of what is and wasn't possible before.
Dai, I noticed there's a question on LinkedIn.
Yeah, do you want to take that now?
I want to take that now because it kind of relates to what it is. The question that we picked up, I've just seen on LinkedIn, is views on making Cassandra strongly consistent versus strongly consistent databases. And it's about where you start with your engineering. The consistency model inside your database is pretty important. It's not something you engineer on afterwards. And with Yugabyte, what we recognized was that people wanted a database which had a SQL type layer, Postgres type layer, with strong consistency. But there's also a large use case for the type of store that Cassandra is as well. So what we've done in Yugabyte, and I know we're not busy plugging it, but what we've done is we have delivered that Cassandra API with transactional levels in it, because our engine is transactional. And
can I stop? Not because I want to stop you doing the product rant, Dave, but because I just want to be really clear, is what you're saying here is that the question was, would it be good to put a consistency layer on top of the Cassandra database? And you guys, well, actually, if you want a consistency layer, you have to put it in first and then put the API on top.
Consistency is a huge challenge. It's fundamental to the database. So retrofitting consistency into something like Cassandra is challenging.
I mean, I think the first time they first had lightweight transactions 10 years ago. Yeah.
Probably, yeah, about that. And it's still there. And Mongo's got the same problem. They've got what they call document consistency at the moment, but it's still not firm transactional consistency. So if you want, this is where the different models come in. I'm all in favor. I've spoken already this afternoon about the need for eventually consistent databases in the right use case. I think it's an important way to architect modern data layers. But if you start looking at use cases, regardless of the data model structure that you want, relational or key value or document store, but if you want a transactional database, you need to have that baked in at the very bottom. It's not something you fit in over the top and expect it to be successful, because these come down to the fundamentals of how you shard data, what you do about the consensus in distributed systems, what you do about availability, what regions you want to do. It's not a sort of, it's not a sort of bolt-on. And my flag against this is if you look what has happened with monolithic databases. So with monolithic databases, what happened is eventually we went from the idea of you have a database in a data center. We all grew up on that one. And then we started moving to having to have two data centers with databases, and we started putting replication or log shipping or flash storage or whatever it does to move. move things between data centers for resilience. And eventually what you've got is your database. And this is when I was talking about Oracle being an ecosystem. You've got a database, and then you've got 5,000 tools to make it do solve the one business problem that you want to solve. And that business problem is to have a database which is available in multiple regions and will survive node failure and not have to think about replicating and doing the other things, and is transactionally consistent. So retrofitting with these things, in the case of the question, whether it's the consistency or the resilience or the replication or whatever it is something that tools do after the design stage. Think about Oracle. Oracle, I mean, I'm ancient, and Oracle is, surprising words here. Oracle is 50 years old now in terms of designing concept. Yeah. Oracle is 50 years old, and the world was a different place in terms of building that. And yet there are still people who are putting new Oracle systems into the environment. And Yugabyte, is a young company. We're 6 or 7 years old, and we are building on the shoulders of giants. So, we're inspired by Google Spanner, and we are using the technologies. So Postgres, which is the most common database, Cassandra API, and our goal is to build a transactional database to fulfill that transactional need. Our goal is not to fulfill the eventual consistency, which there is an eventual consistency need out there, and it's not to finish the analytical the analytical space with a database. And if I look at a modern organization, Christian works a lot in analytical space, and we've known each other for a number of years. I remember a time when Christian and I would talk about data warehousing. You and I have done this as well in the past, and there was operational and analytical. But the more that things change, the more that they come together. So a business solution now, and we've stopped talking about the analytical, the data warehousing, the organization, and the transactional system. In a microservices architecture, what you have is a group of services delivering an overall business functionality. And doing that, what you're going to have is one of you mentioned, I think it was Netflix or Spotify, but all the same models. So the next best choice movie on Netflix is an analytical purpose. Buying the movie as a transactional purpose. And then, eventually consistent is, these are movies you might like. It doesn't actually matter which one you get because they're trying to do these ones. Presented through one user interface with 5, 10, 15, 20, 100. I think it's Amazon who've got 400 microservices which feed one page in their website. And then underneath that, different technologies. Distributed, highly available, transactional. That's a Yugabyte solution. Eventually consistent, locally caching, Redis perhaps. Or analytical, doing the next best offer with an analytical database. These are a range of tools, which is why you can't go out and solve the problem once with one tool. You can't just go out and buy a hammer. You have to take these things in to build these architectures correctly.
Mm-hmm.
Sorry, I get all passionate about this one because I think
no. But that was triggered by the question we had from somebody who's listening in today. So let me just, for that person, is go back to it. Is what you basically said, David, is that kind of transactional and distributed are so fundamental that just as Oracle never added in 50 years, never added, distributed to the rock solid transactional model. Yeah. Likewise, Cassandra has not only been at it for 10 years, added transactional consistency to the distributed model, and kind of Yugabyte had the benefit of hindsight of both of those people, took the very best of both of them and stuck it together. Yeah. And incidentally,
there's actually a little bit of history and why we got to that point as well. Karthik and Kanan, two of our founders, were the Oracle core engineering team for 10 years, and then they were at Facebook, where they were co-creators of
Christoph. Been on both sides of that fence, really.
So we have had the argument and decided that we built two different things which didn't quite work in those sense, and now we think that for this one space, not for all spaces, but for this one space, we've got an answer which helps with that sort of thing.
Yeah, but that was the point being that you also reiterated, and I think Christian, you agreed with that, is even if you can make this powerful tool that does a better job, or rather it does the consistency job, but now does it in the modern cloud native world, i.e. distributed, that doesn't say you don't need streaming, message handling, you don't need HTAP, you don't need analytic, you don't need, as Christian was talking about, the machine learning, AI. You may have a whole bunch of other tools that are delivering up those 400 services you talked about for Amazon, David. Yeah.
Yeah, absolutely.
Yeah. Christian, when David talks, and indeed me too, from where we are right now, we're kind of, our home territory is a kind of a microservices, cloud native applications with some kind of data on the back of it. That's actually not quite the same as what you're doing, is it?
Yes and no. So I've worked quite a bit with microservices in the past, and my last job before I created my startup was actually where we built an infrastructure. But now I'm in a startup. It's a smaller world, right? You can evolve and move much faster. I think the angle you're coming from when you say the analytical side is not the same side necessarily as the microservices, I'd need a whiteboard and probably half an hour to go through this with an architecture diagram. But basically, in the simplest way, think of a bunch of microservices that can communicate either via APIs or via backend streaming like Kafka or some other ways, right? And then you will have a separate layer which basically sucks up this information, this public available information, that public as in like whatever context your services are public. They may be public within a department or within your organization. They may not be out in the wild, to then do the analytics on it. So they are two different ways, but they belong together as a larger architecture. So that's how I have constructed and designed it in the past. And there's many ways of doing it. The benefit of doing this is if you have your microservice and it has its own concern and it has a public interface to the world, right? It can do whatever it wants internally in theory, right? So if I build a relatively small microservices that, I don't know, does greeting cards on my website, then how they store their data internally and what their data model is internally, who cares, right? Like I assume the engineers who built that are professionals, and if everything fits into an SQLite database and that fulfills their SLAs and reliability, go with God. But if they want something more reliable or different, they will use something else or Mongo, whatever. But that gives them the agility to evolve that microservices under the hood in their own speed and their own liking, and depending on what they need to do. But the public data, as it is shared, right, as we discussed earlier, you have to have a certain contract, either via the API or the data schema that you share across your organization or with other services. When you start hoovering that up, that information that is shared between these services, that allows you to make these analytical decisions, right? So I want to know, like, if a user comes on my Netflix or Spotify webpage and they interacted with the playlist and the library and the podcast and their favorite wish list and their star tool and whatever else, right? Like there's a dozen of microservices under the hood, and they will send out messages around like how things have happened, like who has interacted with them and why, or they may communicate otherwise with other services in an asynchronous fashion. You can then suck up this information and do your analytical work on top of that. Now, if you want to build a machine learning tool that does that, right, you'd be mad to do that querying or the processing of that in something like Yugabyte, right? Like it wouldn't be built for that, and it would be probably in a too expensive proposition. But you can move that then into your traditional data lakes. Like you may have a Hadoop cluster lying around, or you may have like some Spark clusters, right? And you can do your processing there. Or you have your Snowflakes or other technologies where you do some of the querying. Or Databricks is another good example here. You have your Databricks where you do the processing. Or maybe if you're thrifty like myself, you may do some of this in Athena, right? Like you can get away with a lot of stuff if you know your way around the tools. So you can go a long way on these things. And then, but with the output of that may actually feed back into the microservices, right? So I may build a machine learning tool, my machine learning model there that tells me like what preferences a user has or what recommendation I should make on their playlist. And that may then actually be delivered back into a microservice where it will operate in near real time, interacting with my customers and my users. I don't know if that answers your question.
Sorry, Dave.
No, pick it up, David.
No, I want to give an example. One that Christian and I both worked on is the idea of fraud payments and fraud detection in a banking transaction system, because I worked at a bank for a long time, and in payments. And when you tap your credit card, you get 100 milliseconds to authorize that transaction to go through or not. And that's built up of a lot of things. It's first got to communicate to the payment company. They've got to check the balance. That's important. And in that time, you can afford to trigger off and do a minimum amount of analytics on that very small piece of machine learning, which says, is this likely to be fraud or not?
Sorry, David, to interrupt you. Like you're talking about the inference, right? So
yeah.
Like I think it's important for the viewers to distinguish between them. Like what I was talking about is like this heavy lifting machine learning.
Well, I was just going to say, that's what.
Sorry, interrupting you.
No. You're right to correct my terminology. That's no problem. But in order for that model to have responded, that inference to have come from, there has been some piece, as Christian said, of heavy lifting done in the thing. So that piece of heavy lifting done happens. It builds up features which go into probably into a transactional store. It feeds up scores which may go against people. If this sort of person does this, then flag this. It generates events. So all of this is what I was trying to get across before, is these are now a series of sophisticated interactions. There isn't a hard line down the middle which says, this is what we do in analytic, this is there. Providing the solution, because the world's changed with Agile. And what the world's changed to is, people used to talk about building something, IT provide this. Now we talk about business value. Business value, you're looking for, how does business value come from delivering this solution? What value does it add to the business? And the answer is that solution needs to have some elements which are highly transactional, because at the end of it, from a business perspective, you want to be doing something useful. If you're Netflix, you want to be selling movies. Let's be blunt about it. They're not in it for free. They want you to be doing something useful. That's the transactional side of it. They want to give you a user experience. That's great. And that user experience is close to the user. It's fast. It's where we've talked about eventual consistency and things. And then it's got to be wrapped around with next best offer type things, the sort of thing we were talking about preferences with Netflix or Spotify, or it's going to be protected by fraud detection or something like that, which is again another analytical function. And we keep looping back around the same story, which is perhaps why we're doing this webinar. But the same thing is here. It's that business value is driven by having the different components in one solution to the customer, to the business, delivering that user experience, delivering that, the important business value, the core transactional component, and delivering the protection or the insight around it to help that product get better. All three of those three features at the front end, the business value, relate to how you build the applications in the middle and how you store and manage the data at the back end. And I think there's actually a surprising correlation down the stack between those ones. I've got Dai looking puzzled. This must be dangerous.
No. I'm always puzzled. I think that's my role here, actually. But no, you kind of like, you both of you talking about, oh yeah, we need to do this and microservices, and then how this multiplies the potential componentry all up and down the stack, not just across the data layer. And Christian, you got closer to addressing this particular problem, which is when you talked about the balancing, the exploiting the experience of teams that you've got versus trying to have some kind of consistency and a more manageable overall environment. You must have both seen this plenty of times. You know, how do you, as a guy really, really high up, let's just not say chief architect, but the guy who's up here in the architectural world of a very large enterprise, how do you do this balance of individual choice for agile teams to create the biggest business value as quickly as possible versus having some chance to kind of standardize this and make it, you know, at least some things get used twice the same. Yeah. When we say heterogeneous data layer, I don't mean one of everything, do I? What do you reckon?
This is a very touchy topic, because this is where technology and humans meet, right? So leading people, not managing them, is difficult. And leading people with a lot of experience and passion, which you normally find in technology organizations or technology parts of an organization, is very, very difficult. Because everyone has a good reason why they think and believe what they believe, right? And if you have worked with a certain technology for 20 years, right, it's comfortable, and it's uncomfortable to move away from the technology. It's uncomfortable to move out of that space. There's a few scenarios that I have encountered. So when it's non-critical stuff, microservices, I tell the people, like, go with your instincts, try out what you need, right? Like, whatever, I don't care, right? Like, you build it, you sort it out, you're adults. When it is strategic technology, there's two modes that I've gone about. It's like, oh, we have like a deadline, we have to move at 100 miles an hour, or we have a certain cost problem, or whatever else. Is I tell people, I explain them, I have an architecture, like a logical architecture, I discuss the certain technologies that we would plug in there and for what reason, and then we can have a good discussion. And if we don't have time, then we either come up together with a solution that we all are happy with, or if we disagree, then I do the benevolent thing and tell them, shut up and do it the way I tell you, because I get paid to do that and I have a bit more experience in it. But that's kind of the last resort. Like I don't default to that because people have good ideas and good reasons. If I have a bit more time and money, I like cookoffs. I really enjoy cookoffs. So because the space we operate in is so fast. Like 10 years ago, Hadoop was the coolest thing in town and the latest thing. No one wants Hadoop anymore, right? It's dead in the water. So that's 10 years, like 10 years of development, boom. Technology rose and died. So today we live in another world. So what we have to do, like for myself, I don't get to do a new job every 5 minutes and a new architecture every 5 minutes, right? So you have to expose yourself to the idea of being wrong and to expose yourself to the idea that there might be a better way of doing things. So every now and then, when I have the luxury of a little bit of time and a little bit of money, I do kind of the paperwork and read across and ask around the teams what their experiences are and make a short list of vendors that I think might be interesting. Look at their websites, have a chat with them, and then try to shortlist them to a very small number, 2 or 3 or something like that. And then do a cook-off with where I invite them in and say, okay, you put in some effort, like you bring in a solution architect or a field engineer or a solution engineer, someone, right, who has some technical knowledge, not a salesperson, please. And we come with a business problem, with a realistic problem, and maybe you can give us some credits. I don't know, maybe, especially in startups, that's always nice. And let's try and prototype a solution, right, and see how that works. And that is usually very, very illuminating. It's illuminating for a few reasons. One is, it's not only the technology, it's also the organization you get in bed with. So I had like organizations where I spent months talking to probably a dozen salespeople until I could find a person with technical knowledge that could actually answer a question, right? And it's just utterly frustrating if you reverse engineer someone else's technology based on the errors and the limitations of whether that it projects in your use, right? And you basically contradict them until eventually you get the number of the guy who actually built the thing, and you can sit down with him and talk about it. I don't like working like that. Other organizations have actually technical people at hand to help you, like already assessing, like, is this even a good fit, right? And really good organizations, they will come in and say, this is not a problem where we play. I can see down the road you have a problem where you play. And I've done that when I was on the consulting side, on the other side of this fence, right? I've been on both sides, so I know the game. Where you go in and say, like, you know what, this is not where we play. I'm not going to force you into this, but next year you're going to have a different problem. Then call me, and that's where we will play. But that helps you to understand who you're working with and how invested they are. But again, also be careful, right? Like some people bring in the show horses and pull them away, like once you have bought and signed the contract. Sorry, one more point, Dai, then I'll give you back the baton. The other thing is test realistic workloads. I cannot tell you how many times people fall into this trap where they try out a tool and they have a toy problem. And it's like, oh, it works great with this toy problem, right? The real world is difficult. It scales, it's messy, it has SLAs, it has lots of different problems. Test for them, right? Like, and I fell in once with a tool which we adopted because we ran out of time, and the person I charged with twisting is like, oh yeah, I didn't have time to load the table up to that size. Well, that was a year wasted because I signed a contract for a tool that basically, when we hit that scaling factor that I wanted, basically fell over. And you only find that out when you actually do the work on them, right? So do that legwork, and it'll teach you a whole lot about the organization and the tools and the technology, and probably about your business problem, because it's another thing also. Don't only just ask your vendor to come in and be prepared. To actually do a proper cookoff, you have to put a lot of effort in on your own side, preparing data sets, preparing NDAs, preparing reasonable use cases, right? Having some of the best people you have down tools on something that's probably critical, features you want to build, things you want to get done this quarter, and move them across to do a cookoff. But on strategic technologies, like that is essential for how you operate, it is worth it sometimes.
Yeah, no, I think it makes some good points. I mean, like you and we both know it, I've been on the other side. In fact, we've reversed roles on occasions with each other. And it's important. One of the challenges Yugabyte has is a transactional database like Oracle has been there for 20, 30, 40 years in some of the organizations that we talk to. And somebody has to put a signature on a thing for a purchase order to move to this new technology, which doesn't work the same way as you've always developed it. Yeah, we are different from Oracle. We're different for a reason. Give you high availability, strong transactional consistency, Postgres, all those things. But making that decision means exactly what you said, and I'm so pleased. And you and I have discussed this previously, Christian, that it is about both a two-sided investment. You've got to come to this party with what you're going to do, but also with some honesty and transparency about it. I mean, I've made, yes, I'm the Yugabyte employee here, and therefore I'm the one talking about it. But hopefully my team will always come at this approach that we are transactional as a system, we're distributed. This is the right place, because if you don't, it's interesting what happens on both sides. You highlighted what happens inside the organization. It's a waste of investment, but it burns credibility. And it also is a waste of your side. If you're a salesperson and you're forecasting a deal because you've got into a proof of concept, but it's the wrong use case, you're wasting that money. It's not just, it's a waste of money on time on everyone's to push this thing. So the culture, it's the thing that, we want to value. We want to value, you talked about where humanity touches technology. You want to build, it's built around that relationship. You want to trust the people who are talking to you about the technology that they're providing. And at the same time, trust the client as well, that they're invested in trying this out. And if it comes to the end point, that you're going to do the right things with it, which is a bit off topic, but I think it's an important, it's actually,
because kind
really
of
important stuff.
Yeah, I hadn't anticipated that question going in that direction, but it's actually really interesting, because I think what you've both said, or different parts of and overlapping, is this idea of if quick and dirty, we got to get it finished now, and it isn't strategically important, then let a team just go with what they want. But if it's strategic, you're probably going to end up in some kind of cookoff, bakeoff, POC, and then you both flipped over and started talking about being the kind of the vendor in that situation, and you both said it about the well, Christian, you said it more explicitly about saying this isn't, we don't play in this space, and you walk away. And David, I know you because I mean I've sat in on some of your team meetings, and I know you say no, we're not doing a POC unless it's the right use case. So my question to you both is, if I'm like somebody who is if I'm a buyer and I've got these vendors lined up, is my best tactic is to offer them, really enthusiastically offer them a use case which I know does not fit their proposition. And if they accept it, I know they're wasters, and I walk away.
That's an interesting one, because that's the M&M's problem. I forget which band it was, but one of the big bands used to put a requirement to put brown M&M
right.
in.
I think it was AC/DC. Yeah.
Put it in their contract to find out whether people ever read the contract and did the honest thing with them. If you're going to do an evaluation, if you're going to look at some software, if you're going to do these sorts of things, that's one tactic. It's probably a very short-term tactic. But the other thing is explain what you're trying to achieve. Because if you're buying a screwdriver and you're used to using a hammer, you may not actually understand what you're asking. Now, this is an interesting challenge.
Comes back to business value, isn't it?
Yeah.
What are you trying to achieve?
Value. Yeah. So yeah, if you say, well, a distributed system, minimum of 3 servers, and they say, well, that's going to be more expensive than my 2 servers, which I've got as high-have configuration. Well, actually, it doesn't have to be. You need less resource. You have to explain this problem.
Yeah.
You have to explain the business problem, not how do you replace my. If you're happy with. It's a strange thing that people do, but they talk about replacing the technology with almost a like for like. You've got this new, very sophisticated database, and we'd like you to replace it in the way that we already use our existing one. The journey we're on is about change.
Yeah.
And go on, Chris is it but you get the gist of what I'm trying to say. The good organizations will both be honest with you, but you need to ask advice. You need to be open and transparent about what it is that you're trying to achieve from business value with it. Christian, go for it.
Sorry, that was totally like giving me flashbacks in very bad ways. Because the last 10 years or so, right, like the advent of big data and Hadoop and data science and machine learning have been also the signs of marketing ultra hype and this FOMO, this fear of missing out, right? I cannot tell you how many conversations I was in and how many companies I've seen that have failed with big data, with Hadoop, with data science, because they went in with the idea, I cannot miss out. Like everyone is doing this Hadoop thing, everyone is doing this big data thing, everyone is doing this data science thing. Let's do it, right? Like let's hire a data scientist, let's get a Hadoop cluster in. All you have done is create a cost. You've done nothing else. You have only wasted money and time because you're not going in with the question, as you say, right? Like David, just to make your point here, is go in with the business question that you can't solve at the moment, the thing that's chafing you, the thing that's hard, that's not working, right? The actual and what the value would be to solve it, and then talk to the vendor and say if they can solve it better. And of course, this is where the tricky part becomes, because 9 out of 10 vendors will say, like, of course, we can solve your problem and better than anyone else. But probably only 1 or 2 of them are truly in there. Because sadly, if you have worked with sales teams, there's many organizations out there that are a little bit too heavily geared to close a contract and not enough to have a long-term relationship. Well, that's a different story. Yeah, so this fear of missing out, ask yourself, if you look at vendors, if you look at technologies, what is the problem I'm trying to solve? Like, what is the business value proposition? And not like, how many clusters should it be? Should it geographically distributed? Like how shiny can it be? How many nuts and knobs and bells and whistles and new tech does it have? no one cares in the end, right? Because your boss probably will only care of like how much money you made and how much cost you saved. And that's where you have to look.
It's really funny because we started this conversation. The question I wanted to answer today was that how do I decide, well, do I need more than one database in my data layer? And the implied answer being, yeah, duh. And how many of them is it? And which ones are they? And how did you decide which ones to use for what? And we kind of like you wrapped that up in about 10 minutes. Well, yeah, duh, of course you do. And yes, you need to look at the problems you're trying to solve at the business value. And then we had a much more interesting conversation, which built on that, which is how do you operate as an organization that is doing that? Yeah. And what was really interesting, and I think actually what made it possible, was that both of you have been in the position of a service or product vendor selling something to organizations trying to do that, and also being on the user side, commissioning those services and buying those products, which allowed you both. And I watched you both like nodding and smiling and grinning at each other when you recognize, yep, I've been there. I mean, possibly in some cases you were both there at the same time, maybe even on opposite sides of the table. But I think, I don't know whether I should be pleased that the answer to what I thought was kind of like a technical discussion about how you examine use cases to, for particular kinds of technologies like transactional databases or eventually consistent databases, turns out to be look at the business value and look at the people that you've got doing that job and the processes, the human processes, which become much more important. I think I'm actually pretty close to running out of time.
We're out of time.
So I'm going to wrap up. Yeah. So I think it's about technology is great, but you need the right people to push it and pull it in the right direction to solve business problems. Thanks very much, gentlemen. That was great. Cheers.
Thanks a lot, Christian. Cheers.